All right, gang, today we're going to talk about Domain 2 of the CompTIA A Plus Core 1. First things first, if you haven't done so, make sure you watch part 1 of the masterclass. This is part 2, so make sure that you watch part 1 before you come here. Just understand that networking is one of the top 3 skills every tech professional needs to know. So just pay super close attention to everything. This domain ties into the actual certification and in real world troubleshooting. So it's only 3 things that are required for you to attend this here training. Number 1, you need something to take notes with. Number 2, you need a functional brain. And number 3, you need the ability to sit down and shut the hell up. We ready? Let's get into it. Now, you may be asking, who the hell am I? Why you should listen to me? Well, I'm an Army vet. Now, I got 2 twin girls. I got 20 years in tech, over 12 certifications, got an MBA in this stuff. I've taught more than 15,000 students with the Master IT training company, and I am the best instructor this side of the Mississippi. Now, what I want you guys to do right now for me is to tell me where you guys are from, where you are right now, and what's making you want to get into tech. Just take a couple seconds and put that in the comments for me. I want to know where you're from, where you live right now, and what is making you want to get into tech and get certified. So there's a couple basic networking concepts. You have to understand the fundamentals and just the terminology. So there's different types of network setups. You can have a LAN, which is a local area network. You can have a WAN, which is a wide area network. That would be the internet. And then a LAN would pretty much be your home network. A PAN is a personal area network, which is just a bunch of different mobile devices that are connected over short distances. Then you have a MAN, which is a metropolitan area metropolitan area network. Just means that it covers one city. And then you got a WLAN, which is a wireless local area network. Now, most models are going to be client server models, meaning that somebody provides the services, which would be the server, and somebody receives the services, which would be the client, right? So in a client server model, the client requests resources, access to stuff, and then the actual server gains permission and gives you permission so you can gain access to these things. Now, another thing is packets, right? Packets and protocols. So the information, the stuff, the emails, the bits and the bytes that are going across the actual network is referred to as packets. And there are protocols that govern all of these different packets, all this different stuff. And protocols is just a fancy name for rules and regulations, right? So all of these packets are transmitted over the network and they contain essential information. So you want to make sure that you're using a proper protocol so it gets to where it needs to get to. Most of the time, this stuff is automatic, and all these things happen behind the scenes, so you don't have to really worry about them. But you need to know certain protocols, certain port numbers, and the way that packets travel across the network. One of the basic concepts that you need to know is something called the OSI model, and that is a logical representation of the way information flows through the network. All right. Now let's talk about some of the devices that you're going to run into when it comes to networking. So you got routers, you got switches, you got access points, you got a bunch of different devices that you need to be aware of, right? Let me get myself out the way. So, oh shit, we're gonna go back. We are here. All right, so we got routers, switches, access points. So there's a bunch of different devices, but these are the main ones that you need to know. And this is a super basic level, right? So a router just directs traffic between networks, all right? We're on my network. I want to go to ESPN, which is a different network, and we will go through a bunch of different routers to get to ESPN, which is going to be on a different network. Now a switch, it actually connects devices all in one network, right? So if you want to go from switch to switch, you want to go from switch to laptop, you will do all that stuff inside your internal network. Now, access points are just something that are simple, and it just extends the distance and the radius and the access point to your network, right? So you can have a repeater, you can have an extender, and it just makes sure that no matter where you are in your house, no matter where you are in your neighborhood, so on and so forth, you can actually access what you're trying to access. Another one is a modem. So that's going to be internet access directly from your ISP. Most routers are modems as well. So it's a router and a modem together. Then you have a firewall, which is going to be set up. It can be set up on your router. It can be set up on your laptop. It could be a software firewall. It could be a hardware firewall. But a firewall just simply keeps all the bullshit out, right? Anything that you don't want on your network, it won't get on your network because of your firewall. So it filters out all of the stuff you don't want and makes sure that all of the stuff that you do want ends up on network. Now, there's a couple different standards, frequencies, and security protocols that we need to be aware of, especially when it comes to a Wi-Fi. So anything that you see that says 802.11, when it comes to protocols or anything like that, is going to be dealing with Wi-Fi. And there's different standards, there's different levels to Wi-Fi, going from A all the way up to AX. Now, depending on what your setup is, depending on what devices you have, depending on what's going on, depends on which level and which, whether A, B, D, AC, AX, N, whatever, what you will actually use on the network. Now, when it comes specifically to the actual exam, we need to understand the difference between 2.4 and 5 gigahertz stuff, right? So 2.4 gigahertz is usually for a bigger area and bigger distances than 5 gigahertz, right? But the only thing is, it's a lot slower and it's a lot more crowded than 5 gigahertz. And 5 gigahertz is faster, but it's usually performed a lot better and a shorter range, right? So going back to the Wi-Fi standards, A would be one of the oldest ones, while AX would be one of the newest ones, right? So AX, actually 802.11ax covers Wi-Fi 6, and it's one of the newest standards, but it's still going to appear on the actual exam. So the biggest thing is just understanding 2.4 gigahertz, 5 gigahertz, and does 802.11a, does that work on 2.4 or 5 gigahertz? Does 802.11n, does that work on 2.4 gigahertz or 5 gigahertz? And just basic Wi-Fi troubleshooting is another thing that you have to make sure that you are proficient in. So basically, you need to know how Wi-Fi works, what's the best standard for your given scenario, and how to secure everything, right? So most of the times, WPA2 is going to be the strongest encryption, right? As far as reliability and actually making things happen. So you got to make sure that you know how it works, know what standards you need to use, and know how to secure things. Because you want to make sure that the data integrity, meaning that when I send this stuff exactly the way it was when I had it, that's going to be the way it is when you see it. You want to make sure that this shit is the same across the board for each user. And you want to also make sure that there's no unauthorized access, right? Only people that we want on the network, only people that we want to see this stuff is going to be the people that's going to see this stuff. Make sense? All right, so now let's talk about some network services. So here is just a few network services, but these are foundational things. These are the things that we have to know, right? So we need to know DHCP, DNS, and NAT, network address translation. So make sure that whenever you see acronym, you know what it stands for, you know what it does, you know how to fix it if it's broken or if it's missing, right? So network services and just network troubleshooting in general, you have to know the different services, the ports that they run on, and what the differences between these things are, right? So DNS, for example, that's going to translate a IP address to a website name. So every website has an IP address. That's how the network figures out where to send stuff, right? But it's easier to remember past techsearch.com than it is to remember 198.2.1.1, right? Or whatever the IP address is. So the IP address is just the logical address, and DNS simply translates that IP address to a website name. Now, if your DNS server isn't working or if it's something messed up, a lot of times if you put in website name, it's not going to come up because it can't figure out what IP address is tied to that website. So it's just going to come up with nada, or address can't be found, or broken, or you're going to some type of error message. Another thing is DHCP. So we already talked about IP addresses, and what DHCP does, which is Dynamic Host Control Protocol. So what that does is it actually automatically assigns IP addresses to devices on your network. Then the DNS, which is domain name server, that's what translates IP addresses to website names. Then last but not least, network address translation, or NAT. All that does is it makes sure that your private IP address, right? So your private IP address when you're on your network can be routed across the public network, right? So when you're on your network, you have a private IP address. When you leave your network, you have a public IP address. You can only route public addresses, all right? So network address translation translates your private IP address to a public IP address so it can go to other networks, other websites, and leave your actual network, right? Another thing that you want to be familiar with is TCP versus UDP, all right? TCP versus UDP. TCP makes sure that things get to where they're supposed to go to, right? UDP does not give a damn. Email runs on TCP. YouTube runs on UDP. So TCP cares if things get there. If I send you a fucking email, I want to make sure that it gets there, right? But if I'm watching, I don't know, reruns of Teenage Mutant Ninja Turtles or something on YouTube, I don't give a damn if it skips a beat or something, right? Because I can just ask YouTube, I can refresh, I can just ask for it again, right? So usually streaming, anything that's streaming is UDP, or anything that has to make it to where it needs to make it to, like email, is going to be TCP. And just a couple different ports that you guys need to know. You need to know DHCP, you need to know DNS, you need to know these different networking services ports. So every service, every protocol works on a port, and that port has a assigned port number. This is all logical, right? So it's not a physical port that you can see, it's a logical port. For example, DNS runs on port 53. Email protocol that is super popular called POP3 runs on 110. HTTP and HTTPS, where HTTP is not secure, then HTTPS, when you're on a website and you see the little lock, HTTPS is secure. The unsecure version of the internet runs on port 80, while the secure version of the internet runs on port 443. Now, there's literally thousands of different ports, right? These are just some of the ones that come to mind. These are just some of the ones that you may need to know, right? But I will say this: when you're studying, when you are doing the things you need to do, my students have found that it's about 50 to maybe 75 ports that you really not even necessarily need to know, but that may come up, right? So don't, when you see thousands of ports, you're not gonna have to know every port. As you study, as you keep on going through different things, you'll start seeing the same shit over and over again. It's okay, I probably need to know this, right? All right. So now I want to talk a little bit about different cabling, right? So this information, this data needs to be traversed, housed, moved through different types of cables, right? So if it's Ethernet, if it's fiber, no matter what it is, it needs some type of cable to ensure that it goes to its destination, right? So most of the cabling that you're going to see inside your home that's going directly to devices, or if you're at your job, it's going directly to a device. Most times it's going to be a category 5 or a category 6 cable. Okay. So depending on what you're doing, these speeds can vary drastically. Fiber, of course, is way faster than Cat 5. Now, when it comes to Cat 5, there's a connector that goes on the end of Cat 5, and that's going to be called a RJ45. It kind of looks like an old little telephone connector, but it's a little bit bigger. So that's what you terminate with, or that's what you close the cable ending with, right? So one of the biggest hurdles, one of the biggest things when it comes to Cat 5, one of the limitations is that if it's unshielded, which means that if you lay it on top of something, if there's any type of interference, any type of vibration, any type of radio frequency that can potentially penetrate that cable, it may mess up the data that's going through it. An unshielded twisted pair. Now, when it comes to Cat 5 that is shielded, it's wrapped around. It has things that block off any type of radio frequency or any type of vibration. Then that's going to be a lot more sustainable than something that is unshielded, right? Now, when it comes to fiber, fiber is usually what's going to be what you're going to be feeding off of from the main source, the main hub, right? So most of us don't have fiber going directly to our home, right? We may have be connected to a fiber connection, but it's probably most likely there isn't an actual fiber connection going to our home. Although there are neighborhoods that are starting to get fiber, and that is amazing because you get gigs and gigs and gigs of data at a time, which makes internet streaming faster. It makes everything that you do so much faster. Now, like I said before, there's different type of connectors when it comes to cables. So for the Cat 5 and Cat 6, it's going to be RJ45, while the telephone cable would be an RJ11. And like I said, different categories can be Cat 5, Cat 6, Cat 7. And just like the radio frequency stuff I was talking about earlier, it depends on what you're trying to do, which one of these would make the most sense for your application, right? Now, one of the things I want you guys to do is to tell me this in the comments. When it comes to fiber, there's a single mode and there's a multi-mode. What is single mode best for, and what is multi-mode best for? I'll even narrow it down a little bit more to give you a fucking hint. So is single mode better for distance or speed? Is multi-mode better for distance or speed? Put that in the comments and I'll tell you if you're a damn dummy or not. All right, so another thing that comes to networking, one of the biggest things is the IP addressing, right? So we talked about this a little bit earlier, but there is 2 different versions right now. So you got version 4, then you got version 6. So version 4 IP addresses have run out. So most devices now are going to be running off of a version 6 address. And that's pretty much all you need to know for that. So like we told you earlier, like we talked about earlier, the difference between public and private IP addresses. So public IP addresses are unique, right? And they are routable across the internet. While private IP addresses are only used inside of local networks. So you can't give every device inside your local network the same IP address, because it's going to have an error and one of the devices isn't going to be able to actually work, because it already knows, like, hey man, I already got this address. Just the same thing why two houses on your block or two houses in your neighborhood won't have the same address, because mail and information would get messed up. So when it comes to going across the internet, when it goes to hooking up in your network, it's a couple things that you need to make sure things actually work. So you need an IP address, right? Which is going to have your IP address, your subnet mask, and your gateway. Your gateway is what actually gets you out of your network. It's a gateway to another network. And then the subnet mask just determines how much of the actual IP address is for the network and which part is available for, host devices. So how much it is, or how many of these IP addresses belong to the network, and then how many devices can actually go on this network. So you got a network portion, then you have a host portion. The host portion is where the devices go, and then by subnetting and give things a subnet mask, it allows you to be a lot more efficient with IP addresses. Instead of just giving a bunch of IP addresses away and wasting a bunch of IP addresses, you get the exact amount of IP addresses you need. Now, earlier we also talked about a DHCP, right? DHCP gives you a IP address automatically, right? So let's say that the DHCP server is messed up. Let's say that it ain't working right. You'll get an APIPA address. APIPA is just automatic private IP addressing, which just means that, okay, for some reason we couldn't connect to the DHCP server, so let's just give you an IP address but the only thing is you won't be able to connect to any of the resources inside of that network, because it's not recognizing your device as part of the network, because you didn't get a goddamn IP address, right? And just quick troubleshooting, as I always say, you got to be great at troubleshooting. If you look at the IP address and it starts with 169 or 169, that means that you have an APIPA address, right? Before we go any further, I want you guys to go over to passtechcerts.com and take their free tech career quiz. In a couple minutes, you'll find out which field and tech you should be in and which certifications best align with that field to help you land a job as fast as possible. passtechcerts.com and go over there and take our free tech career quiz. The next thing I want to do is actually show you guys what's possible. I know passing these certifications, getting a good ass job, actually doing the stuff that you want to do can kind of seem impossible. So I want to give you guys some real world examples from real people that have done what you're trying to do right now. So sit back, enjoy this inspiration, and then we'll get to the rest of this training.
The no-nonsense approach to the way that you were communicating and the material that you had on YouTube, and so far as the materials that you already had on there, it spoke for itself.
One thing I wanted to ask
is don't feel nervous. Boost up your confidence and go in there like you know you're going to pass. Because if you do that, that's what I did. I changed my motivation and I said, okay, I'm going to pass this. And I walked in there and, I walked into my house because I was testing from home. And I said, okay, I'm going to pass it, and then you pass it. And you don't pass it by a little bit when you do that, you pass it by a lot.
From ITF Plus all the way down to Security Plus inside his course. After the course, I got my first IT job, and so far, so great. A lot of the stuff I'm learning, I learned in the course is being applied to my job. I know not every job will tackle everything, but a lot of stuff is like, hey, I learned about this in this course. I'm like, my manager's like, hey, do you need me to review this with you? And I got it down. So it's helping a lot.
His courses are very straightforward, they're self-paced, and he'll make you fall in love with IT. I promise you. If you are just really motivated about getting IT, Dwayne's your guy, and he won't fail you.
Before the program, I always thought about getting in tech. I consider myself like a knowledgeable end user, but kind of never really knew where to start. About 3 months ago, and now I have 3 certifications, actually 4, because one of them's stackable.
You really simplified what needed to be known. You go over the objectives, and you kind of simplify and you focus on that. And that's the most important part.
there's a lot of basic foundational stuff that I didn't know.
Exactly.
You know, I'm kind of glad I'm getting like the certificates one by one, you know?
I think like maybe doubled my salary.
Unbelievable. It was just like, I feel confident I passed because like the questions and stuff, everything was just clicking to me like clockwork.
And after watching, when I signed up and I watched your first video, I was like, why somebody didn't explain it to me like this the whole time? Like this just makes everyday sense.
And I liked it a lot. I also like how you explain things. So you explain them very clear, and I think at a speed where it can be, you know, like processed, and you very down to earth. You don't make people feel stupid.
I learned more about computers in about an hour watching Dwayne's videos. I recommend it.
By yourself, definitely not. I'm sure people could, but I think having a good layout and then also having videos to look at, having information to look at, and then, you know, I talk with people in my cohort. We were able to talk and get through things, and I think you start to also have like an accountability partner.
Thank you so much for taking a holistic approach to this thing. You understood that it was much deeper than just getting a certification. You knew that people like me also needed to have the services of the.
All right, let's stop it there because this gonna keep on going. I put too many damn reviews. I put too many damn reviews on here. But anyway, those are people that was in the Zero to IT Pro program, which is enrolling right now. But I want you guys to go and take the free tech career quiz first. If you love it, if you like it, if it comes back with some results that you love, then we can talk about me helping you go ahead and get into the program. But right now, I want to finish domain 2. That's what we're here for. So let's go ahead and get into the next part, which is going to be talking about network setup, right? So network setup is important, but we're going to just go through some simple stuff, right? So it's going to be a lot of network setup questions on a lot of the CompTIA exams, A+ to be included, Network Plus, Security Plus, and you want to make sure that you understand the basics for sure. So SOHO just stands for Small Office, Home Office. So there's a couple of different things that come with network setup. Your name, of course, right? The fancy name for the Wi-Fi password, right? So you go to McDonald's, you see McDonald's Wi-Fi. The fancy name for that is the SSID. So you make sure when you're setting up your network that you give it a name that you can remember, that is something that is easily recognizable, especially if it's going to be a lot of people using it, and make sure that it is secure as possible. So a lot of times, if you're at your home, you can hide your network name so that way your neighbors won't see your network name. Because I know a lot of people try and do like, I'm gonna name some cool shit, FBI surveillance van, and that's usually, you know, the shit that people try and hack. But the SSID is the name of the network. So that just stands for Service Set Identifier, and it's a fancy way to say, hey, this is the name of the network. One of the biggest things you have to do, whether you got Verizon, Xfinity, Comcast, whatever, whoever you have your internet through, make sure that you, whatever the default settings are and whatever the default security stuff is on the router, please, you can pause the damn video right now. Please make sure that you change whatever the generic default passwords are for your routers to something else, because you can literally Google the manufacturer. Anyway, I don't want to tell you how to do it, but just make sure that you change stuff just to keep yourself a little bit more secure. All right. But last but not least is port forwarding. So that basically allows you to make sure that a certain device can use a dedicated port for itself, right? So you can allow internal access or external access to specific devices to your network. All right, so we got a couple more things, then we're gonna wrap it up. All right, so network troubleshooting. Troubleshooting is always going to be, what the hell are we talking about? Troubleshooting is going to always be one of those things we're going to come back to, right? So some of the most common stuff is no connectivity. I can't get on the internet. I keep losing the internet. I keep on losing my connection. So whenever that happens, if it's a wired connection, make sure that you check the physical stuff first. We always check the easiest stuff first. I'm not saying that's going to be what the problem is, but it's going to save you a lot of headache and heartache if you just check the physical stuff first and check the easiest stuff first. Now, if it's not a wired connection, you need to check to make sure that okay, is my Wi-Fi on? Am I trying to connect to the right password or to the right network? Let me try and restart this phone. Let me try and restart this laptop. Let me try and restart this tablet to see if that works. Or is it in airplane mode, right? Other thing is DNS issues. Remember we said that if the DNS isn't working right, it's going to seem like the internet does not work. So if you got DNS issues, then this is going to be pretty rough for you, especially if you're a novice user. You'll think that, the internet is either out or not working. Another thing is slow speeds. That could be for a multitude of reasons. It could be the cheap ass internet you're using. It could be too many people on your network. It could be limitations on your hardware. It could be that your stuff is out of date. So many different things, right? When it comes to networking, there's a couple software tools that you definitely need to be aware of and know how to use. So here's a few. And remember at the beginning, you're supposed to write shit down. So you can also pause. But Ping is one. Tracert is another one. ipconfig is one. NSLookup is one. Ping, just make sure that you can actually communicate and send packets to stuff that's on your network and outside of your network. Tracert traces the route of routers, right? So if for some reason you can't connect to something, for some reason you can't get to your destination, you can use Tracert because it will literally trace the path that the information is going. All right. ipconfig shows the IP configuration for a device. Then NSLookup is going to look at your DNS and a few other things to make sure that everything is the way it's supposed to be. Everything is set up properly, right? Some of the physical things that you need to know or going to run into are going to be cable testers. That's just to make sure that your Cat5 and stuff like that is actually working correctly. You don't have any broken pairs or anything like that. You can also use like a toner probe to actually send a tone down the line. It'll show you if there's any issues or where the other end of that cable actually is. A toner probe comes in really handy if you run into like a server room or something that has nothing that's labeled. A toner probe is really good for that. Another thing is making sure that you understand the troubleshooting steps. So the first step is going to be identifying what the hell is wrong. So identifying the problem and establishing what you think happened and what's going on. So establishing a theory. Third is testing what your theory is. 4 is implementing whatever the hell you think the fix is. You do that. Then after that, you verify functionality, meaning that whatever you're supposed to fix, you fixed it and you didn't break nothing else and everything is good. And last but not least, document everything that you did. So today we talked about basic networking concepts, wireless networking, cabling and networking, version 4 and version 6 addresses, and network troubleshooting. So now we're going to do the infamous 1 question quiz. Just 1 question, have you think about it, and then let's see what you think. A remote employee reports that they cannot access any websites while working from home on a company laptop. They confirm that they can successfully ping their home router at 192.168.1.1 and can also ping a public IP address such as 8.8.8.8. However, all attempts to ping domain names like google.com or microsoft.com fail. Other devices in home are browsing the internet normally. Based on these symptoms, what is the most likely cause? Is it A, the Ethernet cable is faulty, B, the home router is powered off, C, the laptop has an incorrect or missing DNS configuration, or D, the laptop has assigned itself an PIPA address? So when we in the actual exam room, make sure that you pay attention to that stuff. What's the most likely to cause? What's the first thing we should do? What's the last thing we should do? What's the most expensive? What's the least expensive? 5, 4, 3, 2, 1. So hopefully you picked C, because remember, everybody else is rocking out. Everybody else is good. Most likely the DNS is misconfigured. Why do we say that? Because when you put in an actual IP address, stuff comes up. Stuff is working. But when you put in a website name, it's not working. That's because the DNS is misconfigured. Now, this is all I need you to do right now. I need you to do 3 things. Number 1, comment certified if you're going to pass the A+ in the next 30 days. Number 2, make sure that you take the tech career quiz, which your ass already did, but if you didn't, don't worry about it. Maybe you were just too excited. Go take the tech career quiz. And number 3, make sure that you watch part 1 of the master class, which is what the hell you're supposed to do before you even watch this video. But if you didn't, you still had time to redeem yourself. Other than that, I'll see you in class.